Right, in this video, I'm going to provide the explanation for the homework questions from assignment 2.1. Right, let's look at this question. Right, so a town council decides to set aside a rectangular piece of land for a community garden. So the piece of land is X meter long and Y meter wide. So if you recall Mr. Poya's problem solving methods, he said one of the method is you can draw a diagram. So this is exactly what we're going to do. We're going to draw a diagram to represent your community garden. So in this garden here, in this rectangular piece of land, okay, we're going to let the length be X meter long and the width will be Y. Okay, right. So part 1, we're asked to find the area of the land, and that's pretty easy because the area of a rectangle is just length times breadth, which is just XY only. And perimeter, basically you just add up all the length of all the 4 sides, so that will give you 2x plus 2y. So part 1 is relatively easy. Right, let's go on to part 2. So for part 2, you're given that the area is 216 meters squared. So we just equate xy equals to 216. Let's call it equation 1 because there will be 2 equations. So we're going to solve them simultaneously. So we can call the first one equation 1. Right, second one, you're told that it's enclosed by 60 meters of fencing. So that refers to the perimeter. So 2x plus 2y will be equals to 60. Okay, try to simplify the equations before you do any substitution. In this case here, I can actually factorize 2 out. And I can divide by 2 on both sides to give you 30. Because 60 divided by 2 gives you 30. Right, I'm going to make x the subject here. And I'm going to substitute 2 into 1. Okay, so let's see what I get. I would have y multiplied with 30 minus y equals to 216. So 30y minus y squared equals to 216. Negative y squared plus 30y minus 216 equals to 0. Okay, I'm going to multiply by negative throughout to make negative 1. Multiply by negative 1 throughout to make the coefficients of y squared to be positive. So I'll get y squared minus 30y plus 216 equals to 0. Okay, you can try to use a quadratic formula, but before you use quadratic formula, try to factorize it first because this one refers to the length of the rectangle, so it should be a whole number. So let's try to factorize it first, because if you use quadratic formula, sometimes it can be quite time consuming. All right, so what are the possible values? 216 or what times what gives you 18 and okay, I don't have a calculator here. Never. 216 divided by 18 times 1, 18 to 12. Okay, 216 and 12. Right, okay, so y can be 18 or y can be 12, right? Okay, so what's the next step? You are asked to find the dimensions. Dimension meaning you have to find the values of x and also the values of y. So the next thing is I need to do is I'm going to substitute y equals to 18 into equation 2 to find the values of x. So substitute y equals to 18 into equation 2. All right, you substitute into equation 2 because equation 2 you already make x the subject, right? You already make x the subject in equation 2, so therefore it makes sense to substitute into equation 2. And then you substitute y equals to 12 into equation 2. You have x equals to 30 minus 12 gives you 18. Okay, so therefore, right, therefore the dimension, depending on what you let your x value be, okay? If you let it be 12, then the dimension will be 12 meter by 18 meter. Or if you let your x be 18 meter, then it will be 18 meter by 12 meter. Okay, because when we work out, we have two different values of x. So we have to answer it in this way. It's either 12 meter by 18 meter or 18 meter by 12 meter. All right. Right, let's look at this question here. Right, so you're given two equations, and you're given that these two equations intersect at the point 1p. So one of them is a curve and one of them is a line. So you have a curve. So when it intersects, the curve intersects the line, it could intersects at 1 point or 2 points. So what we're saying is that it intersects at only at this point here, 1, p. And we asked to find the values of p. Okay, so there's only one value of p. So what do we know? So what we're going to do is we're going to substitute x equals to 1 and y equals to p into which equation? Into our 2p squared x minus 5y equals to 7. We have to substitute into both equations. In the end, you have to substitute. All right. So we substitute into 2p squared x minus 5 equals 7 first. Okay, so p squared is just p squared. X is 1. All right, so you end up getting a quadratic equation where you can factorize it to give you 2p minus 1, no, 2p minus 7, p minus 1. Okay, so you end up getting 2p equals to 7. 2p minus 7 equals to 0. So 2p equals to 7, p equals to 3.5. Or p plus 1 equals to 0, so p equals to negative 1. So which answer do you reject? Because if you look at part 1 here, there's only find the values of p. So that means there's only one values of p, right? But here you end up getting two values. So what do we do? Right, so we also have to now bear in mind that this pointer also lies on the curve. I think it's not a curve, this is a circle. Also lies on the circle. So I need to substitute that 1 comma p into 12x squared minus 5y squared equals to 7 as well. So we're going to substitute excuse me. Excuse me. Negative 5 divided by negative 5 gives you 1. So p can be positive 1 or p can be negative 1. Okay, so you must remember that the values for p must satisfy both equations. So if you were to compare, right, if you were to compare this value you get with this value you get here, then you see that, right, the common value is p equals to negative 1. Right, so therefore p equals to negative 1 is the chosen answer. Right, so therefore your answer is p equals to negative 1. Okay, this is how you do it for part 1. Okay, so now let's look at part 2. Right, so for part 2, you're supposed to find the coordinates of the other point of intersection. Oh, so what's happening now is that because just You see, so what happened is that we're saying that the curve intersects the line. At first it says it has 1 point only, but when you see the words intersects, it can also intersect not just at 1 point but 2 points. So actually the diagram is like that. The diagram, the correct diagram should be this way. You have a circle, and then yeah, so you have 2 points there. One of them it's 1, negative 1, and we need to find this second one. Okay, that is the second one that we need to find. So what we're going to do is that we're going to substitute. Also, this is part 2. Wait, let me write down this is part 2. We're going to substitute 1, 1 into both equations. So we will have 12. Oh, sorry. We don't substitute into your first equation because the first equation is already, yeah, there's no unknown there. So wrong. So we're just going to substitute 1, negative 1 into just the second equation. Into 2p squared x minus 5y equals to 7. Wrong. Sorry. We don't substitute 1, negative 1. What am I doing? We're just going to substitute p equals to negative 1 into this equation. Okay? To get p bracket negative 1 squared x minus 5y equals to 7, we'll have 2x minus 5y. Okay, so can you see that this will be your first equation? Then the second equation will be this guy here. Okay, then we need to solve these two equations simultaneously. Solve them. Okay, right. So what I'm going to do is I'm not going to make x a subject. I think we end up getting a fraction. So we try to avoid it. Try to avoid making deal with fractions. It's very painful. Okay. So what we're going to do is that I'm going to do is I'm going to examine 12x squared and see if we can just break this guy up. 12x squared, we can break it up as 2x times another 2x, right? That gives you 4x squared, right? Then times of 3. Okay, so right, so I'm going to keep that first, put it as 3. And then from equation 1, okay, I'm going to make 2x the subject. Can you see what I'm trying to do here? Right. Okay, so then you see that I can actually just replace this 2x here, right, with 7 plus 5y. Can you see what I'm trying to do here? I'm trying to avoid having to do with fraction because it's very painful. Okay, so now I can just substitute my 2x with 7 plus 5y. All right, so okay, so this one I'm going to use the algebraic identity a plus b squared. So it gives you a squared plus 2ab plus b squared. Okay, not to forget, have to multiply by 3 later on. Okay, so that will gives you 49 plus 70y plus 25y squared times 3. Okay, and then the next thing I need to multiply by 3. So 49 times 3 will gives you 147. 70y times 3 will be 210y. 25y squared times 3 will be 75y squared. Minus 5y squared minus 7 equals to 0. So that will give me 70y squared plus 210y plus 140 equals to 0. I can divide, I can factorize 70 out. Okay, and if I divide 70 on both sides, I'll end up getting just y squared plus 3y plus 2 equals to 0, which I can easily factorize it as y plus 2 and y plus 1 equals to 0. So I will get y equals to negative 2 or y equals to negative 1. Now y equals to negative 1 is already given, right? Why is it given? Okay, look here. Can you see? We already found our point 1, 1. We already found this guy here. This guy, we already found this guy. Okay, and so can you see the y coordinate is negative 1? So therefore y equals to negative 1 is already given. So the other coordinate is y equals to negative 2. But we still have to find, because we're finding the other point of intersection point. A point must comprise of x and y coordinate. So finding the y coordinate is not enough. So I'm going to continue here. So we're going to substitute. I'll continue using, what color is that? Yellow? No, blue. Continue. So we're going to substitute y equals to negative 2 into which equation? Oh, here, into this guy here, the x3. Okay, this question is rather challenging, I must admit. A lot of algebra. So 2x is equals to 7 minus 10, negative 3. So x is negative 1.5. So therefore, the other point of intersection is negative 1.5, comma, negative 2. Wow, that is very long, super long. Okay, but don't give up, okay? You just have to persevere, okay? Persevere. Remember, no struggle, no struggles, no progress. Okay. All right, for these questions, I actually have done it in class already, but I'm going to use a different method here. All right, I'm going to use a different method to solve this question. This method I'm going to use is rather interesting. Okay, let's see what this method I'm going to use. Okay, I'm still going to combine these two fractions into one. Do a cross multiply. Right, I'm going to make 5x the subject. Okay, I'm going to call this one, just keep it. What I'm going to do now is, okay, I'm going to look at this second fractional equation. Okay, you see, I'm going to substitute for 5x. So I'm going to do something like this. I'm going to just multiply this with 5. Okay? Right. So what do I get? What do I end up? I'll have 10 over 5x. What do you think? Why do you think I want to do that? Because I want to substitute this 5x here, right? With this guy. Okay? I'm going to substitute 1 into 2. So this is I'm providing you with another way of doing it. Okay, I know I've already discussed this in class, but this is another way of doing it. And yeah, combine them into one fraction. Right, simplify the numerator. Also simplify the denominator, because we're going to do a cross multiply. Right, Right, so that will give us 250. Give us 5 multiplied by 50y minus 2y squared equals to 250 times 6. Alright, I think we can divide both sides by 5 to make. So divide both sides by 5, that will give us 50 times 6, that will be 300. Okay, you get negative 2y squared plus 50y minus 300 equals to 0. Multiply everything by negative 1 to make it positive. Or we can simplify further by factorizing 2 out. Okay, and then divide by 2 on both sides. Okay, let's see if we can factorize it using factorization. 150, how much would that be? 75 and no, 75 and 5 cannot. 75 times 2, no. Oh my god. And the calculator, can I just temporarily stop this first? Right, so we can factorize it as y minus 10 and y minus 15. Okay, so you get y equals to 10 or y equals to 15. Alright, so that's not the end because you're supposed to also solve to find the values of x. So we're going to substitute it into equation 1. So when sub y equals to 10 into 1, and you will get 5x equals to 50 minus 20. So x will be 50 minus 20 is 30 divided by 6. So we're going to sub y equals to 15 into equation 1. You get 5x equals to 50 minus 30. X is equals to 4. Right. So therefore the solutions are first answer it's 6, 10. Second answer is 4, 15. Alright, so this is another way of solving these questions, right? Alright, let's look at this question. So it's rather interesting questions because you're not given two separate equations, right? You're actually just given one whole string of stuff like that. But we can actually break it up into two separate equations, right? You can actually either break this up in this way. This can serve as one equation, or this, or this. All right. Okay, so if you combine all these three cases together, you get this that's given in the questions. Right. So which two equations you're going to use to solve them simultaneously? Will you use this one with this, or use this and this? Right. Right. I think we have made the right choice. We would use this and this. And we're going to solve these two equations simultaneously to find our values of x and y. Right, but if you look at this guy here, we can do some simplification first. We can actually factorize 2 out. Alright, so we divide 2 by both sides. That gives you 26 divided by 2 gives you 13. We can make y the subject. Multiply by negative 1. Okay, we're going to call this equation 1. We're going to substitute 1. We're going to call this equation 2. So we're going to substitute 1 into 2. Okay, let's see what we get. So we will have 2x squared plus x multiplied with 2x minus 13 minus bracket 2x minus 13 squared, give you 26. Okay, we expand this guy. That gives us 2x squared minus 13x. I'm going to expand this one here, but be very, very careful. Please put a huge square bracket inside. Okay, and then you apply the algebraic identity. If you don't know what I'm talking, this is what I'm saying. Alright, so you can expand it. A squared minus 2ab plus b squared. Okay, so let's simplify. You realize that solving simultaneous equation is actually not a very difficult concept, but it is difficult because there's so much algebra involved, and if you're not careful, you can just make mistake. Like for example, this one here, this is 2 times 2 times 2 times 13 times x, give you 52x. 13 times 13 is 169. Yeah, and if you never put this huge square bracket here, which is a likely area to make mistake. Okay, so I'm going to emphasize that now. Need a square bracket there. Alright, 2x squared plus 2x squared give you 4x squared minus 13x minus 4x squared. Okay, this is what I mean. Can you see what is the purpose of this huge square bracket? Yes, so that negative times negative give you positive. So if you don't put the huge square bracket there, you end up getting negative 52x, and that will be, you will get the wrong answer, and then you just work so diligently, but in the end the answer is wrong. Oh, so 4x squared minus 4x squared will be gone. 52 minus 13x gives you 39x. So 39x is equals to 26 plus 169, 195. So x will be 195 divided by 39 gives you 5. Alright, so our story doesn't end here. I still need to find the values of y. So I'm going to sub x equals to 5 into equation 1. And I'll get y equals to 2 times 5 minus 13 gives you negative 3. So therefore, the solution is 5, negative 3. Okay, so that's all, folks.